Okay? So adding and subtracting polynomials, also known as combining like terms. We've done it before. It's just that now we're dealing with longer expressions. We're dealing with them in a situation where we have an expression added to another expression or an expression subtracted from another expression. Okay, so just a little bit of review. Let's review what like terms are. Two terms are alike if they have the same variable raised to the same exponent. So same variable raised to the same exponent. If you have multiple variables in the term, those variables would have to be raised to the same exponent to be alike. For example, if we had the expression 3x to the fourth plus 7xy plus 3x squared y plus 4x plus 2xy. So look at that big long expression. We're not actually going to combine them. We're just going to identify the terms that are alike. Make that 4x to the fourth. So add a little fourth up top. So if we were to look, we need the same variable raised to the same exponent. So I have an x to the fourth here, and I have another x to the fourth here. Those would be alike, right? So I'm going to put a circle around each of those, and I'm going to make a note that says those are alike, right? Same variable to the same exponent. Now, if you have multiple variables, each of those have to be raised to the same exponent. So I do have x's and y's here. However, this x is to the first power and this x is to the second, so they are not alike. It has to be the same exact variable with the same exact exponent. So 7xy would be like 2xy. Same variables, same exponents. Again, up to this point, you didn't really have a lot of examples like this. It was, you'd have A's in some and then B's in others. You didn't have a lot of mix, except in our power properties quiz that you guys took a couple weeks ago. A lot of people made a mistake on the part where we had to combine like terms with these. And we're gonna see that. We're gonna see some examples in just a second. Okay. So we're not actually gonna add this. I just wanted to double check and remind everybody about like terms. Okay, so we're just gonna go straight to adding. So we're gonna talk about addition. It will look very familiar, but there are two methods I'm gonna give you. The first one is gonna be the way that we would have completed this before, and then I'm going to give you a new strategy. So for addition, you're going to have two expressions, and they'll be written in with parentheses. They will not always be written in standard form. Most of the time they will be, but not always. All right. So We are going to rearrange. Okay, the first method is like a horizontal method. And this is what you guys have done hundreds of times probably at this point. So we're going to rearrange the expression so that the like terms are together. Now, they are written with parentheses. However, if I look here, there's really nothing I can do inside. There's nothing to distribute. So I can just kind of break down the parentheses and rearrange, right? So I'm going to take what's alike and put them together. So I have a 4x to the third and a minus 3x to the third. I would strongly suggest that you don't try to rearrange and calculate in your head. That's when people start making careless mistakes. Something else that I would suggest is kind of cross off the numbers as you rewrite them so that you don't forget anything. The other thing I would suggest is that you go in descending order of exponents. So I handled my third power. Now I'll take my second power. So 2x to the second. I don't have any more x to the seconds. Now I have just plain x's, so minus x.
So how do you know what to do first?
Plus x. I just start picking numbers but based on the exponent.
No, but x, each x, positive or negative, has an exponent of 1. How? So do you put negative or positive first, or does it not
Doesn't matter. Doesn't matter if you put, like in this case, if I put the negative x first or the positive x first, because we're about to combine them anyway. Okay. I just write them as I see them. So staying organized, double checking, go back through and say, okay, I had 1, 2, 3, 4, 5, 6, 7, and now I've got 1, 2, 3, 4, 5, 6, 7. It seems silly and it probably feels like it's not necessary. But I'm going to tell you right now, people are going to make mistakes if they're not careful. I'm going to have to mark points off and be sad because somebody missed a number because they were rushing or doing it all in their head. So now at this point, I take my like terms and I combine them and get my final expression. So this is not difficult, hopefully. These combine. I have no other x squareds. Negative x plus x is 0. 8 plus 6 is 14. And make a note, we want to write the answer in standard form. So write your answer in standard form. Let me kind of unsmush this a little bit. Okay, so write the answer in standard form. Pretty easy, right? Okay, we're going to do the same expression problem or the same addition problem, but we're actually going to do it vertically. Okay, if you remember when we solved systems of equations, we were able to stack our equations on top of each other, and sometimes like with elimination, we could multiply on both sides and then we eliminated a variable and then we added everything else. We're going to kind of use that process. So I can stack these up, and instead of like place value, I can actually line my terms up by exponent. Okay, so we're going to look at a vertical method. And I'm going to take the same exact two expressions, but I'm going to stack them by exponent. Okay, so I'm going to take 4x to the third. I'm going to put them in standard form as well, just to keep everything organized. You don't have to, but it does help. So for my first expression, I'm going to take 4x to the third plus 2x squared minus x plus 8. So I'm rewriting it in descending order based on exponent. And then I'm going to take that second expression and I'm going to line up the like terms. So 6 minus 3x to the third plus x. So I'm going to take the 6 and I'm going to line it up under the 8. And I'm going to take minus 3x to the third, and I'm going to line it up under 4x to the third. And I'm going to take plus x, and I'm going to line it up under minus x. And I'm going to add vertically. That's a plus sign. So I get 14, those cancel, plus 2x squared, x to the third.
There's a plus sign after 2x.
Thank you. Don't forget the plus sign. When you do your work tonight, you can decide if you want to combine like terms horizontally or vertically. I do too. Keeps me organized and out of trouble. We're going to do another additional one that way. All right, so let's look at another example of addition. So example 2. We have x squared plus 3x minus 4 plus x squared minus 4x plus 7. We're going to add this vertically just because I feel like you have had enough practice horizontally to be able to do that if you want. So these are written in standard form, which is nice. Remembering that standard form means that we have them in order by degree or by exponent. So when I rewrite this, I'm going to take my first expression, and then I'm just going to line up my second expression by term. So x squared under here minus 4x plus 7. Line them up and just add. Keeps you organized, a lot less chance of error. The biggest problem people will find with this is transferring the terms down, making a mistake, forgetting a negative sign, forgetting that subtraction means you have a negative, those type of things. So transferring over, just double check yourself. Questions? Okay, so the last thing we're going to look at is subtraction. Which really turns out to just become something that we turn into addition. All right. So make a little note that we're subtracting. So example 3 is 2x squared plus 3 minus 7x squared minus 4x plus 2. So in 7th grade, you guys learned about the additive inverse. Your teacher probably, I think what I've heard people say is add up or keep opposite opposite, change opposite opposite, something like that. Add the opposite. Ultimately, what we're looking at here is before you guys like line everything up vertically, we need to deal with that subtraction sign. The way I like to explain it, you can go through and change this to addition and then make everything inside the opposite, right? Keep, and then everything's the opposite, or keep this, change that to subtraction, and then everything here becomes the opposite. I like to look at it as we're distributing a -1. just because it's something that's familiar. You guys have seen equations like this. So I imagine this as a -1 that distributes to everything inside. But however you want to handle it, make sure you make a note, change to addition, and then each of these become the opposite of what they were, right? Everything inside becomes the opposite. Instead of just one thing getting changed, it's everything inside. You can imagine it being a -1 distributing. So what we get is we get addition, -7x squared plus 4x, -2. Now you have an addition problem. Now do either horizontal or vertical and add up all of your like terms and come up with your final standard form expression. So now it's your turn. So you can add these vertically or horizontally, whatever you choose. So do that and then check against what I have. If you want to do it vertically, but you're noticing that we don't have the same amount of terms, I'm going to do it here and you can see like how I handle it. Okay, so I'm doing it vertically up here if you want to kind of see what I do. And then check and see if you got the same thing I did. How'd you do? Good?
I'm still working on it. I did kind of like make the steps.
Okay, that's fine. So a couple things about this. One of my expressions has 2 terms, the other one has 3. Remember, with addition, the order does not matter. So if you don't like this, how I kind of left a gap, if that makes you nervous, because it's addition, the order doesn't make a difference. So I could take the expression that has more terms and make that my top, and then put this as the bottom, right? So I could have written it as -7x squared plus 4x minus 2, and then put my 2x squared plus 3 underneath. And I would still get the same answer, right? Okay, or if you do it horizontal, you're good. Okay, any questions? The only thing left is when you get your homework, I want you to look at number 7. You are only going to have to do numbers 1 through 11. So I'm adjusting because we didn't have time to talk about word problems, but we will. So you can kind of take a look at it, but numbers 1 through 11 is what the homework is doing. But take a look at 7 really quick. So 7 has 3 expressions. All you have to do on a problem like 7 is handle that subtraction. So as you're passing back, kind of take a peek. Make subtraction addition, and then everything inside becomes the opposite. So everything inside becomes the opposite, and then now I can just stack all 3 expressions on top of each other. So now all I have to do is take my x squared plus 3x minus 8, and then just start stacking. Thank you. And add them up.
It's the same as number 1.
Mm-hmm.
That's a 4.
Does that make sense? So that's as hard as it gets. And be careful, this negative here is not meaning that I'm subtracting everything. That means I have a -2x squared right there. Right? Do you need one?
Order numbers 1 through 11 or
1 through 11. Yeah, do 1 through 11, you guys. I mean, if you want to, eventually I'm probably going to add the ones on the back, but for now, just 1 through 11.